see the G on the higher value and this one is a lower, but basically I fixed. This is how we calculate the area of this. Okay, if I include on this plate something, I'm throwing some charges on this, okay, some charges inside, okay, then there will be a gauge inside here, XY, okay, this is the gauge. There is a gauge play the role here, okay, the gauge actually coming inside and this gauge actually will do certain things. This is what I'm trying to say, okay, I can pull it up and I can calculate the whole thing. Okay, you look at this again. What is the mistake that I made here? Okay, if it's a single line, it cannot be like that. Okay, you cannot use this. It must be straight. It must be straight. Okay, it must be straight. It cannot be a curve. I cannot use the curve for the single line here. Okay, it must be D1, D2, then it must be a straight. Okay, therefore it cannot be a curve. If I wanted to use curve, then I need to use a 2D already. Okay, I need to use a 2D because I need to use a dy. Okay, dy. Then I need to change this. Okay, although I fix it here, then the dy I need to use here some variable to calculate this, and which I cannot use for the one single things. I need to combine the 2D model. I need to use a 2D here. Okay, I need to use a 2D. It could be with gauge, without gauge. The gauge here, now you can see the gauge. I can bring it up now. The gauge can be a dy dx. The gauge can be a charges like that, or it can be a something the dy dx, which I can pull here like this, similar. Okay, similar to this one. Okay, I can pull it up. Something like this. Okay. Okay, the gauge can be controlled like that. Okay, this can be fxy. Okay, sorry, it's like it could be straight line or it can be controlled by fxy, which is can be a curvy line, as long as you can see. And this one is fixed. Okay, this one is fixed, and you can see we can take the the volume. Suddenly this whole thing, you combine three together, it's look like a volume. Actually you are calculating the volume. Can you understand that? Can you understand this? Actually we are pulling up, we are stretching this, okay, using fxy. This goes, and you can see the gauge is actually playing the role as a volume. It can suddenly change to the volume. Therefore you see the 2D you can calculate for the volume. For the 1D you can calculate for the surface here. Okay, you can use that as a surface. You see, you can use fx, can be a slightly you can use fx to calculate the surface, but this one is able to calculate what we call as a volume. Okay, something very interesting phenomena. If you wanted to calculate the different size of the these things, you can directly use fx here. Okay, the gauge also can help you to calculate this kind of changes here that you are monitoring. This one always will give you a fixed line, straight line only. You cannot calculate. Actually, when you calculate for the C to the C1 to the C, you won't be able to use this one. You need to use a gauge to calculate that. The gauge, you need a gauge help to calculate that for this particular case. If you use like a fx, then you need to bring this to the fx here. Okay, the fx calculations, because you need to here it is a dx. Okay, this become a dx and this is a fx. The fx will control this. Therefore the gauge will make sure something the changes inside here. If you use only without gauge, you will get only straight line like that. Okay, it's a fix, very straight. It's all become a fix. If you without gauge, I'm saying, without gauge, it's all straight. All will be straight line like this. Okay, you will only able to calculate that. for the D. See, it's a straight, okay, just you won't be able to see anything, but the limitation here is a C1 to C2. Whatever is a straight, then you just calculate, then it will be that's what you're able to calculate. Okay, you won't be able to calculate other than that, but the GOES will help you to determine what we call as a the surface. Okay, the surface of that. Okay, similarly you can see the dy dx here. Okay, without this GOES, we can use the 2D to calculate that, but to the x, okay, but still is a line. Okay, now I hope that okay, you can follow. Okay, let me use one simple example to calculate that. Okay, okay, example, simple example for you to see this. If y1 to 9x and y2 is x2 to the 9, find the area enclosed. Okay, find the picture. Okay, find the area enclosed. If the things is going outside of this, then focus is actually enclosed by the curve. Okay, enclosed by the curve. Okay, is it possible for me to calculate that? Okay, just sketch first. Okay, when we sketch, how do we sketch this? This is a y, and actually you can see this is coming like that. What is that? This one is a y2 equals to 9x. That's why you need to master the sketching part. If you don't clear, you're not very sure, very difficult for you to solve this kind of problem. Okay, what about this one? Okay, this. Okay, can you see that? This one is a y2 equals to x2 divided by 9. Okay, now you are required to calculate this enclosed area. Okay, enclosed area. How do we calculate that? The first thing, there are two ways to handle this problem, or two ways to see this. Where do you want to place your eye? First, let's say I'll do as usual, traditional way. Let me place my eye here. When I place my eye, then okay, first, what is this point anyway? What is the point? I think you can calculate this easily. Basically, okay, I'll try to put it this here. This y equals to 9x square root of that. Okay, calculating, and therefore you first this point calculate. This is x2 to the 9 equals to 9x. Therefore you able to calculate this one. This basic x2 to the 9 square root here 9x is x4 9 power 2 is 9x, and okay, this is very important. Simple, but sometimes the student overlook this. Okay, why we need to do this? Don't cut the x straight away. Please do factor fill. When you're making the factor here, therefore you see I can write this equation factorizing, something like that. There is a x actually, okay, cross the x exists here, and one more, you can see there is an interception. You can calculate the x is equals to 9. Sorry, this is not x, actually 9. Okay, this is 9. Then you can calculate that. Okay, you can calculate that. Okay, this is quite good. You will able to see that calculation is something very simple. Okay, hopefully, can you? In this particular case, now I get back to this one. When I place this my I here, A, how to calculate that? Okay, when I placing the I is most important. I stressed several times to you, I is a very important. You are placing your I in the x-axis, therefore this become x1, x2, or maybe x1, x2, no problem. Okay, you are referring to the x. Okay, what is x point here? The point here is a 9. What is the minimum point, last point that you are looking at? Is a 0. Okay, 0. Okay, clear. This one is very clear. Now you are going to see how do we analyze the changes of the y. Okay, how do we looking at the changes of the y? Okay, now in this case you are using a second. Okay, the first one is a dx, therefore please place it that as a dx here. Okay, dx, this is a dx, first one is a dx. Okay, what about the dy? Okay, dy. Okay, now for the dy we need to choose the higher, remember, y1 and y2. Can I looking at 1, y2? Okay, looking from here, from the perspective of x-axis. Okay, this is the x-axis. Okay, x-axis. You are seeing the y. Which one is higher? Very important. Again, I stress to you, which one can be referred as higher for the y, maximum value of y. That means you see this graph on the top. Okay, on the top actually reflecting the higher point. Therefore, you need to take the value of square root of 9x, okay, as your top value, and what is the below? Okay, the below, then this will be x2 to the 9. I hope that you can see that what I'm trying to say. Okay, can you? Okay, first have a look on that. Okay, fine. Okay, with this, can I solve then? Yes, you should able to solve this. Okay, in this case, okay, 9, 0, you can bring this to the dx. I can write this way also, because dx here belongs to this one, and the y is a belong to this part here. Okay, where I can calculate that as a 9x. Here is a x2 to the 9 dy. I solve this first. Okay, I solve this. After that, place this information inside here. Okay, dx, that means I'm not bringing inside, but I'm trying to show, okay, actually dx, actually I'm trying to say you solve this, after that you go inside. Okay, then you get a 27 as your solution. 27 as your solution. Okay, I hope that you can follow my instruction. Okay, now I'll give you one more example. Ex. Okay, this one I wanted to stress to just now, similar to what we discussed just now. Okay, you can see this. What is the idea of this? Some student really confused of this. Y1, 3, Y2. Okay, please remember, it's not a convention. You must put it here x2, x1. I just playing around with that. Don't be so much stick to this kind of things. Actually, it can be x2, x1, or whatever. As long as you know what you are writing here. Okay, x2, y1. You're looking at this. Now, this is what I wanted to tell. These logics here, y2, xy, dy, dx. Okay, this particular case, when you analyze what you are trying to say, first you need to understand the idea here. It's not simply you solve the problem and you can show it to me, okay, this is the answer. It's not important. First you need to understand what is this. What is this? Okay, if I ask you to sketch this, you should be able to say, sir, there is a ghost exists here. Okay, this is the ghost. You should be able to say this is a ghost. Okay, this is a ghost. We call it that as a fxy. Okay, the ghost exists there. Okay, what is this? How to sketch this? Okay, the sketching of this will inform you what is how the ghost actually, where the ghost is sitting on. Therefore, when you start looking at this, the sketching is something unusual. Okay, you can see the sketching is unusual. It's a 2 to 0. Okay, therefore when you place the eye, your eye is here. Remember, your eye is here. Therefore, when you place the eye, you can see something there. Okay, you can see something there, whereby 0 to 2. Okay, 0 to 2. Then, what is the control point here? The control point is 1. 3 to 1. 3 to 1. Therefore, you just pull up here something you can see y1, y2, y1, and this is basically is a 3 and equals to 1. Therefore, this is what we are talking about. And where is the ghost? Ghost disappear already. No, ghost is inside here, or you can treat that ghost as a kind of, I already told you there are two ways to see this problem. One, this ghost is a sprinkled kind of charges sitting on this plate or on this surface. Okay, this surface is I call it this as a y2 to the xy. This is a ghost is actually sitting on this, or you can imagine this as let's say the ghost is actually very powerful. It's not like sitting inside. It can come out. Okay, able to come out from there. Therefore, when you pulled up this, okay, the ghost something coming out like that. Okay, see, it's become 3D. It's become a 3D because of the ghost is actually is this fxy. Okay, the ghost is actually is bringing the surface, using the surface and acting on something, acting on this. Okay, how far it can act is controlled by this one. Okay, y2 xy. Okay, that's something very interesting, right? Okay, the ghost is acting on this. Therefore, this is the idea. I want you to get the idea, complete idea of this. Oh, actually, this is what is going on. Now you can see how the ghost is acting on. Okay, this is volume, the picture of volume. Okay, the ghost is there but acting as a volume. Okay, it's acting as a volume, but here it's a sprinkle charged. Okay, sitting on the some plate surface, something different, right? Okay, you can consider any one of this. Still, it's a workable. Okay, still workable model. You wanted to treat this as a volume, no problem. Or you can imagine this is a depends. Okay, the cases depend on the cases. They will throw to you the questions like this or like this. Okay, in this particular case, we are treating this as a volume. Okay, now with that idea, now we move on to what we call as a polar coordinate. Okay, this is a revision. Remember, I'm doing revision. If you want a further clarification, you better refer to last year. Polar. Okay, polar integral. Polar double integral. Double integral. Okay, polar double integral. Okay, the polar double integral, it works similar to the things that we discussed earlier. Okay, but the model that I introduced to you earlier, you see this again. I revised this carefully. You imagine this is a dr, the smallest, very tiny, tiny angle. There is a tiny angle actually is opening there. Okay, with that, now what I'm doing here, I'm taking a very tiny cut, kind of cake, something like that. Okay, one small tiny cut, which the smallest here is a dr. Okay, I call it this is a dr. Okay, chop it and put it this and see what you will get. You will get like this. Okay, it looks like a very straight line. Remember, this is a very small. Remember, this is very small. But the whole thing here is r, we know. Okay, radius is r. Okay, what about the circumference here? We will calculate as a r d theta. R d theta. Okay, r d theta. Therefore, if get back to this logics dr and this straight line here, imagine this is a equal, but in actual sense you won't agree with me, sir. You may say no, it's not equal, slightly. No, I'm saying it's a too tiny, too infinitesimally small. Therefore, you need to imagine this is a kind of rectangle. Therefore, d theta. Okay, can I now identify the area? Yeah, you will say very easy. Therefore, I call it this as a whole thing is a dA. The dA will be r d theta dr, right? Okay, now you know the formula for the dA already. Okay, now you know the formula for the dA, and every time when we refer to the dA, then the polar coordinate, we're going to use the polar coordinate of this equation. Okay, this equation. Therefore, I won't go too detailed inside and equation here because it will take too long. Therefore, it will be a dA, and equation will cover for the double integral r d theta dr. Okay, we settle with that. Okay, we settle. Then you can place the gauge again. Remember, the gauge can go inside to this plate also. Okay, if the things is go inside, then immediately you need to use f theta r, okay, dA, whereby it will be f theta to the r d theta dr. Please go back to the revisions. I already taught you how to use from coordinate system to the another coordinate system. Conversion concept I already introduced to you. I cannot revise here. You cannot take it and say, oh sir, please again. Okay, I will do very quick revisions with this. If the case is okay, this is, as I say, that's a little bit spontaneous. Okay, my battery going to finish. Okay, now in this first thing that I wanted to analyze here, okay, how do we place this double integral of f xy dx dy or anything? Okay, it can be a y dy dx, whatever. How to convert this into polar coordinate? Please, you must master this. Okay, when you wanted to place, and we know this is a dA. Okay, we know this is for the dA. I wanted to convert to the dA for the things is here from rectangle. From rectangle to what we call as a polar. Okay, to the polar. Therefore the logic that we're going to use is D. Okay, okay, I'll write here. Okay, dA, no problem. dA is a dx dy can be equate to r d theta dr. Okay, now you know the logics of this, right? Okay, you know from here. But what about how to change x to here f theta? Okay, how to change to f theta here? Okay, this one, okay, you need to use d theta dr. How do we find out the d theta here, r here? Okay, the logics that I already introduced to you is, in order to use that, you need to use these logics here. Okay, is for the x, for the y and x. Then every time you wanted to find out the theta, and this is r, you can calculate, okay, the sine base. Basically you can use a sine x, and from there you can find out the y and x. Okay, the basic thing here, sine theta, r sine theta. Is it a correct? Just to ask you, is it a cos theta or sine theta? Okay, this is y sine theta. Okay, this is, we are referring y sine theta, r sine theta. Okay, some of you say, sir, I didn't get it yet. Okay, you imagine this is a y. Okay, r, can you see that y refer to the r? Then you know the sine basically is a y divided with the r. And what about the x? How do we refer the x? X refer as r cos theta. Okay, r cos theta. When we refer r cos theta, this is the convention. Now you can place it this here. The convention is, you can change this as a r for the x representation sine theta. Okay, then for the y, not a sine, cos theta, and for the y it will be r sine theta. Okay, therefore you can change it this to the r d theta. Can you see that? Okay, now hopefully this is how the convention really works, the changing process of double integral. Okay, I already spent more time here. Suppose I need to go to the triple. Okay, this is a kind of revisions. Okay, revisions for the 3D part. Okay, for the 3D we going to see one very important logics that I wanted to emphasize. And for the 3D we going to use now, before we go to the 3D, let me go into detail. I'll go into detail the 2D part here. Maybe a polar coordinate, just because I worried whether you cannot see what I'm trying to say for the polar coordinate inside. Okay, and this one is not complete yet. This one is not a complete. Maybe I try to write this. Therefore x2 to the y2 equals to r2. I missed that part. Then otherwise I worried then some of you not very clearly understood what it is. Therefore r can be referred as this, x2 to the plus y2. Okay, 1. And theta, basically theta can explained as tangent theta can be a x, y to the x, and this is, as you know, this is hypotenuse. Hypotenuse, we use the hypotenuse to calculate here x to the y. Okay, I explain from Cartesian. Okay, we are converting this to polar coordinate. You should able to calculate, because this is the important part. Later we are going to incorporate this Cartesian to the changes. Okay, so far I am not sure whether you can follow me. Okay, with that, is there any questions would you like to ask? Okay, some of you may expect, sir, can you show one single example for polar coordinate? Maybe I'll try to pick one, but something very odd kind of questions lah. Not a common one. Since this is a revision. Okay, let the area enclosed by the polar coordinate, polar curve. Okay, maybe say polar curve r for 1 cos theta, something unusual kind of calculation, and radius vector at r equals to 4 plus 4 cos theta. This is something very unusual kind of calculation for the polar. Okay, I want you to get this idea. Okay, how to visualize this in the first place. Okay, some of you say, sir, I didn't get it that properly, how to analyze this problem. The logics that we can work with this is a 4. Actually, this is the same, right? 4 to 4 but I didn't give you the theta point. Sorry, at here for this is very important, theta to 0 and theta to the pi. If I didn't give you this, then you won't be able to do it that also. You cannot solve. Okay, this one you can imagine something like this. Okay, you try. Okay, you may say, so how do you get this? Okay, you just place inside one by one. Okay, when I place here cos 0, theta 0, I'll get 1, right? 8. This becomes something 8, right? Okay, at the point of theta, then you get a 8, and if I choose this is a theta and this is a r, the r is a 8 here. Okay, when I place the pi here, it's a negative, therefore it's a 0. Okay, okay, can you see that? Okay, this is how we just play around with these numbers, just something like that. Just go up and down, something like this. Okay, you don't ask me how do I sketch this, okay, but if you don't know how to sketch also, you know how to place this, right? It's a kind of curve, but it ending up like that, but it's not a nice curve lah. But you can check certain, okay, you see within this pi, you can take a pi over 2 and check certain numbers, then you know how to sketch already, roughly, I'm saying. Just you place some numbers, then you just plot, you're able to plot this, right? Then shouldn't be a problem. Okay, in this particular case, then you start noticing 1, okay, 2 scenario. Therefore, I don't want to take up too long because my battery going to finish, okay? Therefore, I need to finish this, then I need to start with the triple. It's just nice for me to finish this, hopefully. Okay, now, how do we solve? We start with the theta. I'm placing the I here. Okay, it's a fixed line. Fixed. Always this must be constant. I already told you several times. This must be, when I fix my I, the I must fix to the constant. If you go and fix something, a number which is not a constant, you cannot solve it. Okay. Therefore, I'm placing my I here for the theta. Therefore, theta 1. Okay, theta 2. Therefore, it's a very obvious that we're going to use here is a d theta, but are we going to use d theta calculation, and we're going to solve that. The logic that I want you all to see here is r dr d theta because they want you to area only the curve radius, right? This is the d theta because I'm placing the theta here. Then the next going to be r. Okay, what is the theta here? Pi 0. Okay, obvious. Okay, what about dr? Okay, dr. Is it a dr also is a fixed number? Can be or not? Cannot. You cannot say 80. Wrong. Okay, you cannot say 80 because r is changing. You can see that r is changing, r is changing continuously. Therefore, when you fix 808, what will happen? If you fix it, it will be like this box. Okay, 0 pi. If some of you may say, sir, can I say this? If I say, if you fix it like that, the theta is something, theta is here. Okay, the theta is 0, the theta is pi, and what is that? Okay, the r is 0, r is 8. What is the consequence of this? You are measuring this. You are measuring this. Okay, you are not measuring this because r is changing. R is changing. Therefore, you need to use r. Okay, so on the top, right? You are seeing from there. The top is r controlled by the r1, which is 4 1 plus cos theta, and this is r2. What is the r2 here? R2 is a 0. Very obvious. Okay, r is a 0, right? This is the platform that we are. Okay, this is the question. This is the, see, we already formulate the equation. Okay, okay, can we solve this? Yes. I'll try to very quickly I solve it this. Okay, pi, then when you start solving, okay, r power 2, then you get a, okay, pi to the 0, okay, r2 to the 2, r2, okay, 1 plus cos theta 0, okay, r dr finish d theta. Okay, excuse me. Okay, then this one, okay, I think we need a break if I'm not wrong. This one, and after this I'll immediately take a break then. Okay, this one is a 4 2 because it's 4 2 1 plus cos theta power 2. This is a 2. Okay. Okay. Can we start solving this? Can or not? Can, right? Okay, 16. Okay, just we go for quick way. Just I taking out this, I'll get a 8. Okay, pi 0. This is what I'll get 1, 2 cos theta. Because you see, remember it's a power, power 2, Therefore, you need to be careful with that. This is a cos 2 theta. Okay, cos 2 theta d theta. Okay, therefore you need to expand this. This is, you cannot straight away solve this. Okay, therefore you need to work a little bit different. Okay, this one become theta 1, no problem. This one 2 sine theta. I hope that you can change this to equation, whereby I'll show you later. Sine 2 theta, okay, 4, and this is a pi to the 0, where you get a solution equals to 12 pi. But what is this? Again, I remind you several times, I always used to say that, okay, cos, always you can write cos 2a equals to 2 cos a minus 1, right? Therefore, in order to get a cos 2a, you can put it that as a cos 2a plus 1 divided by the 2. Okay? Therefore, you need to substitute this inside here. Okay? Inside here to get this. Or you can use a different concept also. It's I up to you to solve the things, but I want you to take a note on this. I don't know whether the solutions coming because half is there. Okay, I'm just quickly solving the things. Okay, please, if any, you try to solve that first, whether you are getting the correct solution or not, and you can comment on that. Okay, with that, thank you. We'll take a break, then we continue the sessions for the triple integral after this. Thank you.